Okay, today we're going to take a look at solving systems of linear inequalities. We have graphed linear inequalities. We have graph systems of linear inequations. And that's actually where I want to start, is with an example of graphing linear equations. We know they're equations because they have equal signs. And we should know how to graph these. This is a y-intercept of positive 3. So we got a positive 3. The slope is negative 5 over 3. So it's either negative 5 over 3, or you can do a positive 5 over negative 3. But only one of the numbers gets a negative sign. Because if they both got a negative sign, a negative over a negative is a positive. And this slope says it has to be negative. So that means from this y-intercept, I can go down 5. 1, 2, 3, 4, 5. And I can go to the right 3. 1, 2, 3. And now I have 2 points on my line. So I can connect them with a line. Let's make it green here so we can see. And I have graphed the first line. I am done with that. The second thing is I have to graph the second line. So this line has a y-intercept of negative 1. So I can start there. Its slope is negative 1 over 3. Or it could be a positive 1 over a negative 3. So I can go down and down 1 to the right 3. Down 1 to the right 3. 1, 2, 3. Or I can go up 1 to the left 3 from my y-intercept. Up 1, 1, 2, 3. And I can connect those points in a line. Let's make it red so we can see the difference. And so there is my second line. And when I am solving systems of equations, I need a point. A point will always be the solution. The solution is the point where they cross. They very obviously both ended up right here, where x is 3, so I'm going to put 3, and where y is negative 2. So this is actually my solution to this systems of equations. And we learned that. So now we're going to start looking at examples of systems of inequalities. So what's going to happen is we're going to have a lot of shading on our paper. So it's recommended you have 2 different colors for this. And we're still going to be graphing the lines. So this line would be y is equal to 1/2 x minus 2. So my y-intercept is negative 2, so I put a point there. And this slope is a positive 1 over a positive 2. So that means for my y-intercept, I can go up 1 to the right 2, up 1 to the right 2. And I can connect those points in a line. And it's actually going to be a dotted line because it does not have the equal sign underneath the symbol. So I can connect them with a dotted line. And since it's already solved for y, I see that this is not open towards the y, so that means I need to shade below. So let's pick a blue here, and we're going to shade down here below. And again, it doesn't have to be perfect, we just have to be able to see where it's at. So then I'm still going to come back and graph my second line, my second inequality. It has a y-intercept of a positive 1, and it has a slope of negative 1. So that means it's a negative 1 over 1. So that means I can go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, and that's where my line would go. Or I could have a 1 over a negative 1. I can go up 1 to the left 1. Same difference. When I look at my symbol, it has an equal sign underneath, so I actually need a solid line. I'm going to connect my points with a solid line. Oops, it didn't turn to red. That's okay. And this symbol is not open towards the y. So again, it was a solid line because of the equal sign, and it's not open towards the y. So again, I have to shade below this line. So let's switch to red here. And below this line happens to be this way. So we can see that we've got this area down here where they're both shaded in. And where they're both shaded in, that is our solution region. So down here at the bottom, where I'm filling in more with the black, is the solution region. It includes this part of the line. It doesn't include the dotted line. Dotted lines aren't included. And it includes everything where both of them are shaded. And if I pick a point down here, so this is 0, negative 1, 2, 3. So if I pick the point 0, negative 3, and I substitute it back into both of them, it should make both inequalities true. So if I solve this one, that is negative 3 is less than negative 2. That is true. So that is a solution for that inequality. If I solve this one, that is negative 3 is less than or equal to 1. That is true because negative 3 is less than 1, so it makes the second inequality true. So it's a solution for both of them, so that is why it lies in the solution region, the solution set. It works for both of them, and that's what we're looking for. We're looking for the area that makes both inequalities true. Just like when we graph the systems of equations, what point makes both equations true? Well, it's that point that they have in common, that point that they share, where they intersect. So let's look at one more example. Let's graph this top line in red. So it has a y-intercept at 0, 3. Its slope is negative 2 over 1. And so the slope is negative 2 over 1. So we go from the y-intercept, we go down 2 and to the right 1. And we can connect that with a line. So let's look at our inequality symbol. Our inequality symbol does not have an equal sign. So lets me know it's a dotted line. This is already solved for y. It's open towards the y. So that means y is bigger. So we need to shade above the line that we draw. So let's get our colors going here. And let's get a dotted line. And let's connect these points. There we go. And we said we're going to shade above. So shading above would be over here in this area. And let's get our second line graphed. Let's graph it in red here. Oh, I said we were going to graph that one in red. We graphed it in green. Well, let's graph the second one in red. So this is a y-intercept of negative 3. So I go down here to negative 3. There's the understood 1 in front of x, so its slope is 1 over 1. They're both positive. So it's up 1, right 1, up 1, right 1, up 1, right 1. And let's connect that with a dotted line, because again, there's no equal sign underneath the inequality symbol. And it's going to be shaded below because it is not open towards the y. This means the y is smaller, so I need to shade below. So again, let's do another dotted line. We're connecting those points. Here's my line. And we're shading below. So below this line is this area over here. And so we can see that the area that they have in common is right here, where both colors end up being. And so this is our solution region. So I could pick any point in this area and put it into both of my inequalities, and it would make both of my inequalities true. And then finally, the last type that you're going to have are ones that you have to solve for y. And we'll work those out in class together.